Hi everyone. Today we're going to study optimization. In this video, we are going to minimize travel time. This is the sample problem. An island is 2 miles due north of its closest point along a straight shoreline. A visitor is staying at a cabin on the shore that is 6 miles west of that point. The visitor is planning to go from the cabin to the island. Suppose the visitor runs at a rate of 8 miles per hour and swims at a rate of 3 miles per hour. How far should the visitor run before swimming to minimize the time it takes to reach the island? We put an illustration here for better understanding of the problem. The island is here. It is due north from the straight shoreline. The cabin is here, which is 6 miles from this point. So for step 1, we let x be the distance running and let y be the distance swimming. This is the x from here up to here and the y from here up to the island. Let capital T be the time it takes to get from the cabin to the island. Step 2, we identify that the problem is to minimize capital T, or time. Step 3, to find the time spent traveling from the cabin to the island, add the time spent running and the time spent swimming. Since the formula of distance equals rate times time, or we write capital D equals capital R times capital T. We write here that the time spent running is capital T sub running equals D over R. D sub running over R sub running. So the value here is x for the D over 8. This is given in the problem as the 8 miles per hour. So x over 8. While the time spent for swimming is capital T sub swimming equals D over R. D sub swimming over R sub swimming. And the value here would be y over 3. This 3 here is given from the problem, which is the rate of swimming, and that is 3 miles per hour. Therefore, the total time spent traveling is T subtotal equals x over 8 plus y over 3. We regard this as equation 1. Step 4, looking at our figure here, the line segment of y miles forms the hypotenuse of a right triangle with legs of length 2 miles and the quantity 6 minus x miles. Here is our right triangle. Therefore, by Pythagorean theorem, we can write 2 square plus the square of the quantity 6 minus x equals y square. Simplifying this, we can get the value of y, and that is y equals the square root of 6 minus x and then plus 4. This equation here we regard now as equation 2. We need this value of y in terms of x that we need to substitute in equation 1. So the equation 1 now becomes like this. T of x equals x over 8 plus the y here now becomes this big radical. And we write it here, all over 3. Step 5. From the figure here, we can see that x must be between 0 and 6. Therefore, the closed interval 0, 6 is the domain of consideration. Now step 6. We're going to differentiate the function, the t of x. And then we're going to set this t prime of x into 0, and from there we will solve for x. So we write again step 6 in here, and then we write the function t of x. Let us now do differentiation. T prime of x will be equal to the derivative of x over 8 is 1 over 8 plus the derivative of this will be the constant 1 over 3 times 1/2 times the radicand here will be raised to negative 1/2 times the derivative of the radicand will be 2 times the quantity 6 minus x times the derivative of negative x is negative 1. Now, let us simplify this big expression here. Also, let us set t prime of x into 0. So we will have this 0 equals 1 over 8 minus 6 minus x all over 3 times the big radical here. From here, let us now solve for x. Let us transpose the second fraction on the left side. So this negative becomes positive. And from here, let us do cross multiplication. So our new equation now becomes 8 times 6 minus x equals, this whole radical will be on the right side. Then let us square both sides so that this radical will be cancelled. We have now 64 times the square of the quantity 6 minus x equals 3 square will be 9, and this radical here will now be removed. When we multiply the 9 into the terms inside the grouping symbol and simplify by combining similar terms, we will get this 55 times the square of 6 minus x equals 36. Let us divide both sides by 55. So we will get 36 over 55 on the right side, while the left side will be square of the quantity 6 minus x. Let us take the square root of this equation and then we will solve for x. The value now becomes x equals 6 plus or minus 6 over the square root of 55. We can see that we have two values of x. To separate them, we write x sub 1 equals 6 plus 6 over square root of 55. The second value is x sub 2 equals 6 minus 6 over square root of 55. If we analyze x sub 1 and we consider step number 5, we can see that this x sub 1 value is out of the domain because our domain is from 0 to 6 only. It means this value x sub 1 is not accepted. The x sub 2 value is the accepted one. Now, to justify that the time is minimized for this value of x, we just need to check the values of the function capital T of x at the endpoints, that is x equals 0 and x equals 6, and compare them with the value of the function T of x at the critical point x equals 6 minus 6 over the square root of 55. This is the value that we derive here. We write again this function. So we start with a t sub 0 and we will get 2.108 hours. For the t of 6, we will get 1.417 hours. While for the t of 6 minus 6 over the square root of 55, this will give us 1.368 hours. So we will get the smallest time here. This value can be simplified into 5.19, and of course we don't forget the unit of measurement, miles. This is now the final answer. I hope you learned something from this video. See you again next time.